Alright, so today we're talking about solving quadratic equations. Okay, and what I mean by that is, well, let me fix this camera a little bit here, make sure that you can see it better. Okay, what I mean by that is, we want to find the solution, and to find the solution, it's finding the value of x when y equals 0. What that means is get all polynomials equal to 0. And you can see in these problems they're not equal to 0. Well, we can do something to make them equal to 0 pretty easily. Now, the zero product property says that if a times b equals 0, well, anything times 0 equals 0, right? So either a is 0 or b is 0. And the only way to multiply and get 0, of course, is if one of the numbers is 0, obviously, right? So how do we turn this into a multiplication problem? The better question is maybe a factor problem. Because now, hopefully, you've gotten these factoring stuff down, because you're going to be using that to be able to do what we're doing today. So in other words, to turn this into a multiplication problem, we would just factor it, because when the parentheses are right next to parentheses, it means times. So x, remember, we always find the factors of 6, 1 and 6, 2 and 3, and guess and check. If I plug in 1 and 6, I will get 5x if I subtract them, but then subtract will give me a minus sign here. So it's 2 and 3. Plus and plus, because again, when I multiply these, I'd get 2x. When I multiply these, I'd get 3x, and that gives me the 5x in the middle. So that just set it into a multiplication problem. And what we're going to do with this is now set those equal to 0. I'll show you what I mean as we go here. So hints on how to solve these. The first thing is, if possible, always factor out GCF first. So if there's something that could come out of each term, like for instance in number 3, I can take a 2 out of all of those terms. Okay, we'll get to that. Really, I'd like to have everything over equal to 0 first, so maybe we switch those two around, but it really doesn't matter. Bring all terms to one side. So in other words, let's also make sure that the quadratic term is positive. Quadratic, so in other words, the ax squared term positive. Just a lot easier to factor it. It's not wrong if you don't, but it sure is a lot easier. So that it's equal to 0. Again, we want everything to be equal to 0. Okay. Now for 3, I'm going to put in standard form, which, if you've forgotten, is ax squared plus bx plus c equals 0. Okay? Factor and set each factor equal to 0. So for instance, in this example up here, that was really simple. We would literally set x plus 2 equal to 0 and x plus 3 equal to 0. And say to yourself, what do I do to solve this for x? Well, here I would just minus 2 to both sides, and x equals negative 2. Here I would minus 3 to both sides, and x equals negative 3. And that is what we want as solutions, is x equals. So in other words, we're solving for x when y equals 0. Okay? So here on number 1, it is not equal to 0. So I need to bring the 18 over there, because I'm going to keep the x squared again positive. What do I have to do that? Well, get rid of the 18 by doing the opposite. I minus 18 here and a minus 18 here. Those cancel. I can't combine these, so I literally write it in standard form. X squared plus 7x minus 18 equals 0. Then I need to factor it. Okay. X and x, the factors of 18 are 1 and 18, 3 and 6, 2 and 9. What's going to give me 7? Well, that's of course 2 and 9. So I'll put 2 and 9 in here. Now again, as I said yesterday, I need the outside and the inside to add up to give me 7x. And the only way that happens is if the 9 is positive and the 2 is negative. Now again, what I would do is just always put minus signs in there, and then you have to do an erasing and refoil it to see if it works. This is negative 2x, yep, I need that. This would be negative, nope, I need a positive, so make the 9 positive. Now, again, this is still equal to 0. I factored it, now I need to set each factor, so each parentheses equal to 0. I do that, and do the opposite to get x equals 2. I also do it with x plus 9, you're going to start to see that it really just ends up being the opposite when it's just in x and a number term. Okay? And that's it. That's the answer. Now, could I check it? Sure. Plug in 2. 2 squared is 4 plus 14 gives me 18. It works. Negative 9 squared is 81 plus negative 63 is 18. They both work. Okay? Am I going to ask you to check? No, but it certainly doesn't hurt. Next problem. Again, I need to get this on the other side. Those cancel. 2x squared minus 11x equals 15. Oh, jeez. Plus 15 equals 0, because we have to get it equals 0. That's why I do it in the first place. Now, I can't factor any GCF out of here, so I'm going to go right into factoring. And if you remember, 2x is prime, so I can put 2x and x right away. Okay, equals 0. And the factors of 15 are 1 and 15 and 3 and 5. Now, you would guess and check, and again, the one that you'd want to guess and check with first is 3 and 5. Now, it could be 5 and 3, it could be 3 and 5. I don't know which order, so I'm going to guess and check. Because I don't want to make a mistake here, I'm just going to give you the answer. It's 5 and 3. Now, again, this is 5x. This is 6x. That will give me 11x negative as long as they're both negative, which means both signs are flat out negative. Double check it. Negative 5x, negative 6x. It works. Now again, set each term, so this term and this term, equal to 0. X minus 3, well, that's an easy one. We just add 3, and I get x to be 3. For the other one, hopefully you remember how to do this. You've got to set 2x minus 5 equal to 0. What would you do first there? Well, the opposite of this, which is plus 5. You always do the opposite of add and subtract first. Equals 5. And then the last step, of course, is to divide, which really I could do here if that's a 1 and I divide by 1, but we know how to do that. And a lot of people get confused by this. What do? Just leave it. 5 halves. If you want to write 2.5 or 2.5, any of that is okay, but 5 halves is sufficient. Alright, let's talk about these bottom two here. Maybe try number 3. Pause it, try number 3, unpause it, come back and see my work. To me, when I get to this step, the easiest thing again is to pull out a GCF. Could I factor this right now? Yes, I could, for sure. But if I divided 2 out of every one of these terms, it's going to be a lot easier. The 2 cancels there, I get x squared. I'm also dividing it here, so that's okay. That gives me 2x, and that gives me 3. And now it becomes just a very simple x and x, 3 and 1. I could have a positive 3 and a negative 1 to give me positive 2. Now again, you set each one of these equal to 0, and I get the opposite, and I get the opposite. And there's my two answers. Now for number 4 is a little different. Again, it's still the same steps. I still got to make everything on one side, and I want to keep this positive, so I'm going to minus 5x here. Those cancel. 20x squared minus 5x equals 0. Again, in this problem, when there's no c means GCF. And when you GCF it, so let's put this over here. When you GCF it, it's definitely going to be an x that goes into both of them. What number goes into both 20 and 5? 5. What's the highest letter I can put into both? Well, I can put an x into this, and I can put an x into that. If I take 20 and divide it by 5, I get 4. X goes into there, and there's still 1 left though, minus. Well, 5 divided by 5 is 1, x divided by x is 1, so I just get to there. Now look how easy this is. Now again, what did I pull out? I pulled out a 5x. So really what I have is this. That 5x doesn't go away. I am dividing it out, but it doesn't just go away. I'm just going to now set each factor equal to 0. 5x equals 0. 4x minus 1 equals 0. This one we know what to do. Add 1. And divide. And I get, sorry, I gotta move this down a little bit here. I add 1, and then I divide it, and I just get x to be 1/4. And over here, well, you simply divide by 5. That doesn't mean there's no solution. 0 divided by anything, we've already said, is 0. There's my two solutions. Okay. Why do they all have two solutions? Because of the x squared. They all should have two solutions. Okay. Let's go to the next page. Alright, so on the next page here, we've got a graph of it. And some of you might think, well, what do? I don't even remember how to do this. It's been so long. It's not that hard, I promise. Okay? So, here's the thing. I'm going to take a step back here. We're going to solve this, too. Okay? But we'll show you that in just a second. Let's graph it. What is the axis of symmetry? If you don't remember, the axis of symmetry is x equals the opposite of b over 2a, which is the opposite of negative 2 over 2 times 1, and 2 over 2 gives me x equals 1. Remember, that value is always that value. And to find the y, I just plug 1 in. So I'm going to have 1 squared minus 2 times 1 minus 3. Negative 1 minus 3 is negative 4. Okay. Now, let's plot that point. 1, negative 4, right here. Okay. Remember, the y-intercept is always 0, c, so 0, negative 3, but it's always 0, plug it in. 0, 0, minus 3 gives me negative 3. Let me plot that. And we know this is my line of reflection right here, so I can reflect it right here, and that gives me 2, negative 3. For negative 2, of course, we plug that in, so negative 2 squared minus 2 times negative 2 minus 3 gives me 4. Negative times a negative is positive, and 8 minus 3 is 5. So negative 2, 5, way up here. And again, where's my line of reflection? It's right here, so I got to go 3 from it, so I got to go 3 more this way, which gives me 4, 5. Now that I have those, I can connect my dots, and here's what I want you to see. What you're going to see here is I wasn't 100% accurate, because look what happens. If I were to solve this, solve again means where y equals 0. Well, where does y equal 0 on the graph? Right there on this line. Okay? So right here is a 0, and I didn't draw it right. I should have went right through here, because negative 1 is also 0. I'm going to prove it. Let's factor this. Okay? So I've got x, I've got 3 and 1, I get negative 3 and positive 1. And if I set each one of those factors equal to 0, I add 3 to get 3, I minus 1 to get negative 1, and then again 3 and negative 1 are my solutions. The solutions are where they cross the y-axis, or the x-axis, excuse me. So you can go and check these on Desmos if you'd like, or on a graphing calculator, and it will actually give you the solutions if they're nice whole numbers. Sometimes they don't work out as nice. Your homework is the next 2 pages, which is 1 through 12. That's it. Have a good day.